recorded. And so Tobin's question is really, how to get this guys over? If you simply do the conjugation like this, you won't be able to do that. So I will break down 2 steps. And usually the physics, if you work it many years, you just like, boom, jump into this immediately. But if your first time you did not realize what actually happened, let me do 2 steps. I'm going to show you the step number 1. Let's do this conjugate first. Let's do conjugate first. So I'm going to, because the rest of these terms are similar, let me do the conjugate first. So like this. So this star things only gives you this part. 1/3 e to the positive e2 t, and you only give you this guy, like this, right? So if you conjugate, you only get this plus 2/3 e to the positive e2 t. Oh, sorry, which one is it? In other words, if you simply do the Cobb's conjugation, you only get this. But how in the world do you actually flip them over? Like how this going to flip over? This is the first step. There's no question. Essentially, that's what we did. Second step, we do the integral. So we do the integral, and this integral itself is in the Dirac, in the regular notation, which we will have something like this. So in other words, if we're regular notation, we will have a star like this, and dr like this. In the regular notation, that will be put in this format. But in the Dirac notation, watch carefully. The integral in the Dirac, this is the regular notation. In the Schrodinger notation, let's use S. In the Dirac notation, when this integral itself is interpreted as the left bracket, the broad part. In other words, this integral itself is interpreted in this particular format. So I'm not sure whether you understand what I'm saying. In other words, if without an integral, for instance, if I do not have this integral, then Dirac notation cannot be used. Because this is a multiplication. You cannot use just basically these 2 factors multiply each other. It doesn't make any sense. But in Dirac notation, when you start to have this integral, and then these bracket things comes out. It's just purposely in our mind we flip them in order to conform this is integral. In other words, this is due to integral. Due to the integration.
Oh, okay.
This is due to the integration. If you do not have an integral, sorry, you just go back this way.
And since your complex conjugation is the front term in Schrodinger, that's the front.
Exactly. This was the key. And when I was undergraduate, I also get confused with this so much because the professor would say, oh, like this. But what is hidden here was that this conjugation, but once you add integral, then this bracket becomes like this instead of this, because then this, essentially what you did was you flip this guy to the left, like this. You just move after pass through the integral, and you flip this off. That's right. And the beauty of this was that when you do the multiplication, it's so obvious. This one, that one will be normalized equals to 1. That one will be 0 because it's orthogonal. Okay, that makes better.
That makes a lot more sense.
Okay, so in other words, this step is hidden because it's so easy to write. People just let it take for granted. Say, hey, here you go. You just go for that. So that makes sense. All right, so that's good. Okay, so and then you have a multiple of these terms comes out. Let me pause here for a sec. I cannot pause this, I think.